Welcome to Unit 6, Function Operations. This is Lesson 1, Sums and Differences of Functions. So before this, we've been working with typically just f of x or g of x, and what we're going to be looking at in this unit is how to perform mathematical operations on functions to get a new result for either a formula or a graph. To start, we have adding and subtracting, really straightforward. So we have this function h of x, and what we're doing is just combining f of x and g of x, simply adding them together or subtracting them. So we'll start with the sum. Determine the sum of two functions. So you're given f of x is equal to 2x plus 1 and g of x is equal to x squared. So first we need to figure out the equation of the function h of x, which is equal to f plus g of x. All you're doing is just adding the two functions together. So you can see here we've just, wherever there's an f of x, we've filled in the function for that. And where there's a g of x, we've also filled in the function for that. And then we're simply just adding them together. Now, nothing really changes in this solution, but I did order them from highest exponent down to lowest coefficient so that you're able to see what kind of graph you should be producing for h of x. A typical question that you might get in this section would include to sketch the graphs of the three functions on the same coordinate plane. So you just take the functions, you can make a table of values and use mapping points. We pick a value of x, and then all you do is just plug it into the formula. So when x equals -2, y equals -3. When x equals -2, it's x squared, which is 4. And then in h of x, it's a very similar thing. -2 plugged in would give us 4. Plus -4 plus 1, positive 1. So you can just create this small table of values and then draw your three graphs. Now, of course, 2x plus 1 is a linear graph. That will give us f of x, just a straight line. G of x is a parabola. It's x squared. Just our basic x squared going right through that vertex at 0, 0. And then our h of x is a parabola as well, with some transformations done to it. The next thing that you might be asked to do is to state the domain and range of h of x. And what you want to do is just compare the domain of each of the f of x and g of x and see what are all the values that exist in each function. Now, because f of x is a line that continues off into infinity in both ways, and g of x is a parabola that does the exact same thing, we know that the domain of h of x would also exist as an element of the real numbers. The range, you can just look at your graph, but you would see that the lowest y value you can have is 0. So our range would be y is greater than or equal to 0, and y is an element of the reals. Now, sometimes you'll be given questions, determine how much the function is worth when x is equal to certain numbers. This is really simple. All you have to do is substitute the value that's given for x into each of the functions. So f when x equals 4, 2 plus 4 plus 2 times 4 plus 1 equals 9. G of 4 is 16. And h of 4 is 25. So nothing too difficult there. You're just filling in the value and providing the final answer from that. The next type of problem you could have is being provided a graph of g of x and f of x and being asked to produce the graph of h of x. Now, if that happens, you can do it one of two ways. You can either create a table of values and just plot out all the lines from those values. The other thing that you can do, the x values will stay the same. And then to get h of x, all you have to do is add together the y coordinates from f of x and g of x. So super simple. Now, because these two are linear functions, we end up with a straight line horizontally for h of x. This will not always be the case if you had, say, a parabola or something like that. But the general rule that you could follow is to just add together the y coordinates and plot a new graph. So you would just look at it, say, okay, when x equals -4, y equals +1 and -3. Add those two together, you get -2. It's just that simple and straightforward. Don't make it complicated. The other operation that we can do to functions is to find the difference or just subtracting. So nothing changed from the first part of the lesson. The only difference is that we're subtracting now instead of adding. So this one gives a little bit of a weird shaped graph because we are dealing with a radical function. However, nothing's really changed. Determine the equation of the function h of x equals f minus g of x. So you're just subtracting f of x, or I'm sorry, you're subtracting g of x from f of x. So we have the root of x minus 1 minus x minus 2. That is our function for h of x. Notice that you didn't have to do any math there. The only thing that you'd really have to do is combine similar terms if there were any. Now, this one has a little bit of a trick when you are calculating h of x. Oh, this should be a negative here. F minus g of x. So just make that change on your paper. The function f of x has a domain x is greater than or equal to 1. And g of x has a domain x is an element of the reals. It's just a straight line and continues off into infinity. So the function h of x, it's going to be restricted by the domain of f of x. That's our restriction there. So the minimum value of h of x can only be +1 and all values greater than it. Notice that h of x does not exist past +1 because it's a combination of f of x and g of x. And if f of x doesn't exist past there, then you can't possibly create a value for it. To help explain C, there's a little graph down here at the bottom. So the first graph is f of x. This represents the domain of each of these functions. Now in f of x, the domain exists from +1 out to +infinity. And the same isn't true in h of x because that domain is restricted by the minimum value or the maximum value of each of the functions f of x and g of x. So the domain of g of x here doesn't really matter that much. You just need to recognize that the +1 is your minimum value. And then use the graph to approximate the range of h of x. So from the graph, you can see that it's approximately 1.2. If you said 1, that would be fine. And then, of course, it's going downwards in this direction, so it's less than or equal to that. Sometimes you might come across applications questions. Nothing really changes from what you did in the first two sections. All that's tossed in there is a word problem. So the word problem here, Reach for the Top, is an academic challenge program offered to students across Canada. It's like question, what is that called? Like quiz night, basically. So suppose the cost for t-shirts for the program includes $125 in fixed costs. So that's like the cost to send it off to the printer, and then $7.50 per t-shirt. The shirts are sold for $12 each. So the first thing you're asked to do is write an equation to represent the cost. So the cost of the t-shirt is $7.50 times the number of t-shirts that you ordered plus that 125. So notice that on the graph it starts up here at 125. You have that cost that you need to pay before you even print any t-shirts. The revenue, so that's how much money you're making off of the t-shirts, that's represented by $12 per t-shirt times the number of t-shirts you sell. And that one, of course, starts at 0 because your first t-shirt would give you $12. In B, you are just graphing each of these lines, and it asks you, what does the point of intersection represent? Whenever you're dealing with money or costs associated with running a business, that point of intersection right here at around, I guess, 27-ish t-shirts and about $325, that represents the break-even point, okay? Any further t-shirts after the first 27 that they sell, they are going to start making money on it. Before that, they're not making money. In C, P, The profit is the difference between the revenue and the cost. Write the function representing P in terms of N. So you have these two formulas that you've already figured out, C of N and R of N. And now we want to calculate the profit. Notice that it says it's the difference between the revenue and the cost. So it sets up your formula for you without you having to do any work. It's the revenue, subtract the cost. How much money you make minus how much money you spent. And once you've done that, you can just combine like terms and solve, just leave it in that format there. And it looks like in D, I missed inserting a 0, but copy pasted all 3. So you can just enter in a 0 there for each of the values. So the domain of all 3 is N is greater than or equal to 0. Because you can't sell less than 1 t-shirt, that doesn't, or less than 0 t-shirts, it doesn't make sense. So as long as N, the number of t-shirts, is greater than or equal to 0, then you can define the domain of all 3 functions. Beyond this, you have some practice questions, and then you can move on to the lesson 1 homework.